Okay, good evening, everyone. Happy Monday night. Thanks for joining us for some astronomy tonight. I'm Amanda. I'm the longtime events director for Bookworks, a 36-year-old independent bookstore in the Rio Grande River Valley of Albuquerque. We're very pleased to be hosting some virtual events during the pandemic. Our shop is still closed for browsing, but we are doing curbside service 4 days a week. And you can always buy books on our website, which is bkwrks.com. That's Bookworks without the O's. I will send you a link to Emily Levesque's book in the chat as we get started here. She's going to be presenting The Last Stargazers, a narrative history of astronomy. And she's got some wonderful slides for us to view, and I'm sure some fascinating stories. Dr. Levesque is at the University of Washington. She's telling me before the event that she grew up back east in Massachusetts, but comes from some French-Canadian background. She's in Seattle now, where she studies massive stars, and she recently won an award from the American Academy of Astronomy, I believe, so maybe she can tell us a little bit about that too. In chatting, she was also letting me know that as a graduate assistant, she worked down at the VLA in southern New Mexico, which I think is so cool. We're looking forward to hearing more about her book and about her work. So Dr. Levesque, thank you so much for joining us tonight.
Thank you so much for inviting me, and I'm glad to have the chance to chat with some folks all over the place, but including in New Mexico, one of the wonderful places for astronomy, about the Last Stargazers. So to get started, just as people sort of start coming in, I always like to start by looking at the book as a whole and kind of my experience with starting to write books like this, because my background is as a scientist. I'm trained as a scientist rather than an author. So writing The Last Stargazers was really my first introduction to working in the world of publishing. And something that I learned as I was chatting with authors and like starting to do author events is people would talk about what the first line of their book was, or they would talk about famous first lines of books like, call me Ishmael, or whatever classic opening lines people would like to point at. And they would assign a lot of significance to these very beautiful, very poetic first lines, very poignant, kind of thought-provoking or like cliffhangery introductions to stories. And it got me thinking, okay, well, what's the first line of my book? Like, what am I going to be describing when people ask me this? And I realized that the first line of my book was, as soon as I can get my slides to advance, which they don't seem to be doing, there we go, have you tried turning it off and on again? That's the first line of my book. So a line said by pretty much every IT person ever, and something that we've all heard on the phone when we're yelling at Comcast about our modems, is the opening line of my book about great adventures of astronomy. But there's a reason, because this line highlights one of my most kind of intense or alarming experiences at a telescope. And this happened, I heard this while sitting at the Subaru telescope on the summit of Mauna Kea in Hawaii. So I was a graduate student at the University of Hawaii and using this telescope to study very far away galaxies to try to understand stars dying in those galaxies and the chemistry behind how they worked. And I had been having a wonderful night of observing. It was crucial data for my PhD thesis, so I was very nervous and eager to make sure that everything was working. And at some point during the night, the telescope made this horrible sound. It just kind of went blunk, and I heard one of the computers sound an alarm and then stop. And I looked over at the telescope operator. At telescopes this big, they don't let astronomers run the telescopes ourselves. We have a trained operator who's specially prepared to operate this huge building-sized scientific instrument. And the operator looked at me and she said, well, that wasn't good. And then she says, I think it's okay though. I think the mirror is still on the telescope. I didn't realize it was an option to not have a mirror still be on a telescope. So I got really nervous and started thinking about what could possibly be going on. So to understand what a dramatic problem that is, you can see what a telescope like Subaru would look like. This is me standing underneath a different telescope, the Gemini telescope in Chile. And I'm standing under a mirror that's a little over 8 meters across. The Subaru telescope had a mirror that was even bigger than this. It was about 1/10 of a meter wider, but it was one enormous mirror that we were now worrying about. What we were specifically worrying about was this. This is a photo of another famous telescope in at Palomar Observatory in California, but it shows you how a telescope is supposed to be built when everything's working well. In this telescope, the big main mirror is near the bottom of the screen, and near the top of the screen is what we call a secondary mirror. Light from the sky will come pouring down onto one of these telescopes, bounce off the mirror at the bottom, get bounced up to the mirror at the top, and then bounce again into a camera or some other scientific instrument. And what they were worrying about was this idea that at the very top of that telescope, that secondary mirror had gotten unsupported, that some of the mechanical supports holding it up had failed. So what the operator told me was that if we moved the telescope wrong, that mirror might go sliding off and tumbling something like 70 feet to the floor of the observatory. And that's if we were lucky. If we were unlucky, it would hit the enormous primary mirror on the way down. So this was the alarm that had sounded as I sat at Subaru Telescope that prompted me to place a phone call to the day staff that ran the telescope and made it run. And they were the ones that told me, well, have you tried turning the telescope on and off again? Which again, I had not. I figured you couldn't fix it the same way you fix your modem. And I remember sitting there being terrified and nervous and not wanting to be, the grad student that killed this telescope. I'd heard all sorts of terrible stories about what could happen when telescopes broke. There was this famous example of the Green Bank radio telescope in West Virginia. Now, when I give these talks normally, I usually give people a whole little explanation of what a radio telescope is and how it works. You have this big mesh dish that acts like a mirror for radio light and will bounce light off that dish and up to that little point near the top of the picture, just like a regular telescope. I know I'm talking to folks from New Mexico, and some of you may be very familiar with the beautiful radio telescopes south of you in Socorro. So you are probably more familiar than most folks with how radio telescopes look. You know that they're supposed to look like this. You know that they're not supposed to look like this. This is a famous disaster that happened to the Green Bank radio telescope. I had seen these pictures and this idea was just sort of floating through my mind while I was sitting at Subaru told that the telescope might be broken, but I could turn it back off and on again. So I had this in mind going, well, I don't want to cause that, but I also don't want to give up on this night at this beautiful telescope. Time on a telescope is as precious to astronomers as grant money is to any scientist. We have to be given time on a telescope. It has to be portioned out in advance. And if I had given up on this night because the telescope was broken, somebody else would have shown up the next night to do their own research, and I would have to wait months, maybe an entire year to do my research again. So if I could just fix it by flipping a switch, I could keep on going and do my thesis on time. If I didn't do it on time, then presumably it would wind up in a heap on the floor. So this was a pretty weird situation for me to be in. And this is the story that opens The Last Stargazers. It comes from the idea of comparing what people think astronomers do with what we actually do. Everybody loves to hear about astronomy or see gorgeous pictures of astronomy. We love these beautiful, colorful photos taken by the Hubble Space Telescope. I think a lot of you might have seen a headline or two today about astronomy and this possible discovery of aliens, which I'll get to later on. But we tend to focus on these sort of splashy, exciting parts of astronomy. And we don't know nearly as much about the people that do astronomy and what our jobs are like and what happens behind the scenes. If someone pictures an astronomer, they tend to picture this. It's usually a guy. He's usually standing at this little tiny telescope on a tripod. Look at how small that looks compared to the enormous mirror that I was showing before. He's wearing a lab coat for absolutely no reason. We don't wear lab coats in our job. And he's taking notes or looking through that telescope with his eye. And this bears very little resemblance to what our jobs actually are. When I was growing up, I knew I loved space. I knew space was really cool, and I knew I wanted to be an astronomer from when I was very little. People don't always believe me, but I have photo evidence. This is me when I was 6. I'm wearing my proud, much beloved Hubble Space Telescope t-shirt. Hubble had launched earlier the year and this photo is taken. So I knew that Hubble was cool and I knew that telescopes are cool, but I had no idea what scientists actually did all day. I didn't know what the people behind those cool photos were doing. Most of what I knew about what scientists did for their jobs, I learned from movies, from Twister or from Contact, where we can again see the VLA, or from Jurassic Park. And I figured scientists probably didn't spend quite this much time being chased by what they were studying, but I didn't really know much from those movies about what day-to-day life was like. And I didn't learn about it really until I was halfway through college. So after my sophomore year of college, I got to go on my very first professional observing trip. I went to Kitt Peak National Observatory in southern Arizona for 5 nights of observing time on one of the telescopes on this mountain. And you can see it's this big, huge observatory with lots of different telescopes, and lots of scientists will be there on any given night. So on the first night of my observing run, I went into the cafeteria at the observatory and sat down with my research advisor and a bunch of other astronomers. And my advisor very nicely introduced me to everybody and said, well, this is Emily's first observing run. It's her first time on a mountain. And the table just got super excited. And they instantly started telling me tips for how my first observing night would go, what I could expect. And then they started digging into telling me sort of Wild West stories of observing. Somebody said, oh, did you ever hear the story about the guy that locked himself in the bathroom while the telescope was running? And this is a true story. This actually got written about in a research paper where the author is complaining 15 minutes of telescope time were lost because he got locked up in the bathroom due to a broken door handle. So you imagine an astronomer under a telescope shaking a door going, no, and the telescope is sort of tracking above him and he's desperate to get up there and keep it working. Another person told me about how Kitt Peak will frequently get hit by lightning during thunderstorms. And it makes sense. You've got these big, tall metal structures on top of a tall mountain. And I have since heard from several astronomers who've sat inside telescope domes when they're struck by lightning. Fortunately, they're designed to be kept safe, but everybody says it's the loudest sound they've heard in their life. So these stories come on and on and on. Somebody got locked in a bathroom. Someone was in a telescope that got hit by lightning. Had I ever heard the story about the telescope that got shot? Because yes, that's a picture of a telescope mirror with bullet holes in it. And I remember sitting at dinner with my fork halfway to my mouth, just going, I can't even finish dinner and go observing. I want to hear these stories all night. And I knew what these other astronomers were doing. They were kind of welcoming me to the field with these stories and giving me this little glimpse of what my job could actually be like. So now, years later, after that first observing run, I've tried to share the same experience I had sitting at that dinner table with all of you and all the readers of The Last Stargazers. So this is my new book available now, and it's this behind the scenes peek at life as a professional astronomer. So it shares these human stories and some of the really wild adventures that happen as we try to study and understand the universe. And it uses these stories to communicate both the science and the excitement of the scientists behind all of these great astronomy discoveries. So as part of researching this book, I spent a lot of time both in my work as a professional astronomer and sort of on the side, researching the many different ways that we do astronomy and all the stories that I could dig up. So this took me to incredible places all over the world. The picture on the upper left is me standing in the central laboratory room of a gravitational wave telescope in Eastern Washington. So this is a telescope designed to study tiny ripples in the fabric of space-time. On the lower left is another picture of the top of Mauna Kea. It's one of the best places in the world for studying astronomy. It's also a really interesting observatory with a really complicated history that I was really interested to explore in the book. The picture in the bottom middle is me on my way to Palomar Observatory in California. And that picture on the upper right doesn't look like a telescope, but that is actually a very special infrared telescope built in the back of a modified 747. If you look on near the tail of that plane, you might see a very faint little square door. This telescope is actually designed to operate while this plane is flying in the stratosphere. That back door will open while the plane is in flight, and the telescope will observe light that we can't normally get on the ground because we're still under all the clouds and water vapor in our atmosphere. So I really got to go on some amazing adventures as part of this book research. But one of my favorite things to do was the kind of underwhelming picture on the lower right. This is my trusty little interview voice recorder that I carried everywhere with me in my job for 2 years. And I interviewed over 100 of my colleagues for this book to try and get their observing stories, their experiences, and what they thought a book like this about sort of how we do astronomy should work. So this is, in the end, what I wound up asking people. I really let people tell me their own stories much of the time, but there were 3 questions that I liked to ask over and over. The first was what people thought would surprise readers the most about our jobs. What did astronomers think was the biggest disconnect between what everyone thinks we do and what we actually do? The second was what's their most memorable observing story, sort of secondhand, third hand, 10th hand. What's that weird, legendary, half true story that they totally can't vouch for, but that they love telling people? And then finally, I wanted their thoughts on how astronomy's changed since they had begun observing and how the way that we stargaze has changed. So I'm going to quickly look at each of these questions and pick out a favorite answer or two that I got from people. Now, when I asked people what would surprise someone the most about an astronomer's job, almost everybody gave me the same answer. We don't look through eyepieces anymore. Those little cartoons you saw of men with lab coats looking through telescopes all showed them doing this and looking through an eyepiece. In reality, we very rarely look through an eyepiece anymore. All of our data comes in and is recorded as a photo of some kind. We do occasionally get to look through eyepieces though, and it's awesome when we do, because it turns a bunch of professional astronomers into a bunch of geeking out little kids, inevitably. This picture on the left is a relatively small telescope. It doesn't look that way, but it's a telescope whose mirror is only 1 meter across down in Chile. And I was visiting this telescope as part of my research on a night when the telescope didn't happen to be being used for active research. And one of the telescope operators said, you know, we could put an eyepiece on this telescope just to try and look at a few cool things in the sky. I was there with a group of other astronomers. We all agreed, yeah, that sounds really cool. Let's do that. We put an eyepiece on and we immediately started looking at stuff and devolved from scientists into kids. You could hear people taking their turn at the telescope and just going, ooh, ah, wow. Oh, it's so red. It's so sparkly. It's so cool. And we didn't remotely sound like professionals. By the time I got to look through it, we were looking at this. So this is a star called Eta Carina. And it looks like an explosion. It's not quite. This star is actually still alive and kicking deep inside that blast of material. We think that years ago, Eta Carina actually underwent a huge eruption and flung tons of material off of its outer layers. We have no idea why. We're still trying to explain how this star works. But when you look at it through a telescope, you can see what's in this picture. You see those two little delicate bubbles expanding out of the star. You see the star itself glowing bright red. And I think I worded this when I looked through the eyepiece as, oh my God, it's so red. So this was a pretty unusual, but pretty cool thing to be able to see with my eye through an eyepiece. It was fun, but this isn't how we really do science. Today, the way that we actually observe is using photographic techniques. And nowadays, this means digital photography. Back in the day, it meant something known as a photographic plate. So photographic plates are these thin sheets of glass like the kind that you can see on the screen in front of you. So these are sheets of glass that would get chemically treated to react to light. So you would take a sheet of glass, slide it into a camera, open the camera's shutter, and it would darken where light hit it. So you would get this lovely little photo-negative picture of something like a galaxy. It was a great way to get data, but it was pretty arduous to do. Keeping all of your data on glass, first of all, sounds a little scary, and preparing these glass sheets to be observed was a pretty difficult undertaking. You would have to chemically prepare the glass, slice the glass. Sometimes you'd have to bend it a little bit to fit in a camera. And you're doing all of this in the dark because if you expose the glass to light, nothing happens. So once you would do this, you would take these glass sheets up to a point high above the mirror of the telescope. An astronomer at the time, when we used photographic plates, would sit here. They'd be sitting in this cramped, uncomfortable little spot, suspended dozens of feet in the air above the telescope, loading and unloading glass negatives one by one into the telescope's camera. You would be sitting there for an entire night, unable to get down unless your operator helped you down, shivering usually because it's really cold, sitting in the dark, trying to keep the telescope pointed. It wound up being a really physically demanding way to observe. It sounds kind of primitive, but we would get gorgeous pictures out of it. This is a photo that I took of an old photographic plate, and it's of this beautiful spiral galaxy, kind of like our own Milky Way. So you can see the spiral arms, you can see the stars and gas glowing. They would appear white to us on a black sky if we looked at it through a telescope. And on a photographic plate, it's just the other way around, a pale plate, and then the dark spots where the galaxy's light had hit the plate and reacted with it chemically. So even from this, you could learn a great deal about that galaxy, but we can also compare this to what our observations look like today. So this is what modern observations of that same galaxy look like with the Subaru telescope, the same telescope that I was using at the beginning of the book. So now with digital imaging, we're able to do really incredible stuff with observations, but it's still a bit of a catch in that we get these beautiful color photos that we like staring at after the fact, but we're no longer looking through the telescope with our eyes. Another thing that really surprised people that people said would surprise people about astronomers' jobs is that we have some pretty great adventures. It's kind of easy to think of scientists as sort of geeks hiding out in a basement somewhere, as lab rats that never really go anywhere and do anything, that just hunch over our computers all the time. But in reality, some pretty amazing adventures have happened to people in the name of traveling to the ends of the earth and trying to observe the universe. One of my favorite stories happened here at Monastash Ridge Observatory in the state of Washington, not too far from where I am here in Seattle. It happened to one of our University of Washington graduate students back in 1980, a guy named Doug Geisler. He was observing at Monastash Ridge Observatory in May of 1980. He was actually getting the first night of observations for his PhD thesis. So he was very excited about how well his first night was going. He wrote a log entry, as astronomers always carefully do, describing just how great his first night of PhD observations was. The clouds cleared off at sunset. It was a beautiful night. You'll see in this observing log format that he's very careful to say, I observed for 10 hours. I lost 0 hours. Sometimes someone might say, oh, I lost an hour to clouds, or I lost 2 hours to rain, or something like that. But you can see this glowing, happy log from a perfect observing night. And you also might notice the date, which is May 18th, 1980. This doesn't necessarily ring a bell for everyone, but it always rings a bell when I tell this story in the Pacific Northwest, because the next day was the day that Mount St. Helens, or that morning was the morning that Mount St. Helens erupted. So Mount St. Helens was about 90 miles southwest of this observatory mountain. So Doug had a great night, went to bed, heard this sort of strange rumbling in the middle of the night, but didn't really know what it was and didn't think much of it. And then woke up the next morning to, greet the day and get ready for another beautiful night of science. He opened the door of the observatory and was just stunned at what he saw, because the world in front of him at what should have been high noon was black. There was this awful brimstone smell in the air. He would point a flashlight out the door, and the flashlight beam would make it like 10 feet before just getting swallowed up by the darkness. He thought he was living through the end of the world or through nuclear fallout. What had actually happened was that when Mount St. Helens erupted, the side of the mountain basically blew off, and that volcanic plume went flying right to the northeast, right over the observatory, and right over Doug. So this is what Doug was standing in when he woke up, opened the door, and then went, wow, where did the world go? At the time, you couldn't just kind of check your phone for a news update to find out what had gone on. So he went running back into the observatory and turned on the radio and searched frantically until he found a news report explaining that no, he wasn't living through the end of the world. It was just a major volcanic eruption. Good news in the balance of things. So he, being a very good scientist, wrote a detailed observing log of what had happened. That next day, hours lost 6, reason, volcano, sky conditions black and smelly, and described exactly what had happened on the mountain. He then very carefully covered the telescope because he knew that the ash settling from the volcano could actually damage the telescope's mirror, and carefully drove home. But his observing log entry has now just become the stuff of legend in the astronomy community, because not many astronomers have ridden out a volcano alone on a mountaintop. So this was one of the examples of the kind of wacky adventures that astronomers can experience, and it's where I got the title for the 4th chapter of my book, Hours Lost 6, Reason, Volcano. So to get the full list of chapters, you'll probably want to buy and check out the book yourself, but you'll notice here you can also get a peek at chapter 5's title. And chapter 5 is titled, The Harm from the Bullets Was Extraordinarily Small. It's, again, maybe not a title you would expect to see in an astronomy book, but it gets into people's answer to my second question, their most memorable secondhand or 10th hand story. I was specifically asking people this again because I wanted the unproven, half-true, totally turned into tall tale legend that they'd heard from their advisor's friend's advisor. I was looking for the stories that had just settled into the like background and sort of the ethos of the field of astronomy. And by far, the most common answer I got was, do you have the one about the telescope that got shot? Has anybody told you the story of the telescope that got shot? Everybody told me a different story of the telescope that got shot, and I had quite an interesting time chasing down the story, but it is true. There is a telescope in Texas that was shot at McDonald Observatory, and it was this telescope, the 107-inch. So again, that 107 inches means that the main mirror of that telescope is 107 inches across from end to end. This particular telescope had an employee at the observatory who, it turns out, was not in the most stable frame of mind. And one evening, this employee became hell-bent on destroying this telescope. He went running into the telescope's control room, holding a handgun, brandished it on people, fortunately didn't hurt any people, but demanded that they lower the telescope. He then was able to point the gun down the barrel of the telescope and empty the gun into the telescope's mirror. It sounds dramatic and it sounds like a horrifying way to destroy a telescope, but it's worth keeping in mind just how big these mirrors are. Remember that picture of me standing under the mirror at the beginning of the talk. Telescope mirrors are enormous. They weigh tons. Imagine a Pyrex glass baking dish that's like this thick. So if you shoot a handgun bullet into glass that's that thick, it kind of just lands like a dart on a dartboard. The bullets will basically just go thump and bury themselves in the glass and not much will happen. So he emptied the gun, saw this, and then went, well, that was disappointing. He then started trying to attack the telescope mirror with a hammer, but at this point, the other employees were able to subdue him. The sheriff was called, and he was carted away, and then they got a chance to take a look at the telescope. Now, the sheriff looked at this and went, oh my God, the telescope is destroyed, because he was looking at the big round thing in the middle of the telescope. Now, that's a hole that's cut in most normal telescope mirrors. We'll cut a hole in the center so that light from other mirrors in the telescope setup can be directed right through it to a camera that might be sitting behind the mirror. The sheriff didn't know this. I think he thought this giant, like 2-foot hole had been blasted in the telescope. And it turned out it was fine. They were just able to dig out the bullets that had left those holes. They painted the holes black so that you wouldn't get light kind of pinging around and reflecting, and then happily kept observing. But news kind of got out that, well, maybe a giant 2-foot hole had been blasted in the mirror, maybe it was destroyed, and the observatory's director actually had to issue a small announcement reassuring the astronomy community that this beautiful new telescope was actually fine. So normally when astronomers put out little mini announcements in sort of a regular circular that gets published, it's things like, oh, we found a new exploding star, or, oh, we got some neat observations of a variable star that's getting brighter and dimmer and we caught it at a bright point. And his memo included this. It said, the harm suffered by the mirror from his bullets and the preliminary blows with the hammer was extraordinarily small. So this is where the title for the 5th chapter of my book came from. And it was one of the infamous stories that everybody asked me if I'd heard when I was interviewing people for the Last Stargazers. Another story that everybody asked me about was, well, what about those weird radio bursts? Do you have that story? There were some weird radio bursts a while back and somebody found a funny explanation. What was that? Are you telling people that story? And I love this story too, because it's a great example of kind of slightly funky science going on. So this is the Parkes Observatory radio telescope in Australia. I showed you radio telescopes before. I showed you Green Bank, and we've seen these pictures of the Very Large Array in New Mexico, but it's worth reminding ourselves of exactly why radio telescopes look different. If we sketch out the electromagnetic spectrum, so light at every possible wavelength where it could exist, the light that we can see with our eyes is actually only a tiny part of it, sitting in the middle of the spectrum. If light is a little too short in wavelength, so a little too blue for our eyes to see, it'll be ultraviolet light, the kind of stuff that gives us sunburns, or X-rays or gamma rays, these kind of high energetic lights that we've heard of. If it's too long wavelength to see with our eyes or too red, it turns into infrared light or submillimeter or radio light. And that is the type of light that a telescope like this is designed to detect. It's got that big dish that radio light will bounce off of, just like how visible light will bounce off of a mirror, and it will focus it up to a camera or an instrument, just like a regular telescope. So this telescope in 2007 detected something weird. It detected this brief blast of radio light. And people were a little puzzled and thought, well, we don't really know of any phenomena in the universe that would create a little radio flash. What was this? And a couple scientists got intrigued, saying, well, we could have found this really cool new phenomena. Let's study more of these. And around then, people at this observatory said, well, no, it's probably nothing because we detect these all the time. And it's probably just some weird thing on the ground, but we've never really figured out what it is, but totally ignore it. Radio bursts don't come from space. They come from something on the ground. There's plenty of things on the ground that can create radio interference. Our Wi-Fi signals in our houses, our microwaves, the diesel engines in our car, or the spark plugs in our cars, fluorescent lights. Lots of things will sort of create radio background noise. And any one of these things could have been causing the weird bursts that these telescopes are detecting. So people had just kind of dismissed them. Then there was this one scientist in around 2012, 2013, named Emily Petroff, who wanted to study radio bursts from space. She knew that if these were real, they were incredibly interesting and represented this totally new kind of science, but she couldn't take them seriously until she'd explained where these weird ground-based ones were coming from. So she and the crew at Parkes Observatory set out to explain what could potentially be causing a weird little blast of radio light. So this was their first clue that these blasts were probably coming from the ground and not space. They noticed that the blasts, which they named perytons, it's a mythological creature that looks like one thing but is something else. They noticed that they were all happening around lunchtime, and space really doesn't care when lunch is in Australia. So that was the first sign that something might be wrong. This is an aerial photo of Parkes Observatory and sort of the 3 administrative buildings around it. People worked in all those buildings during the day. They would take lunch breaks and they would say microwave their lunch. So this was their first idea. They thought, well, maybe these events are coming from microwaves. And being good scientists, they went and did this super careful scientific experiment on all the microwaves on the facility. They wrote a research paper describing, oh, this is the make and model of all the microwaves. We tried running them for 10 to 60 seconds. We tried microwaving a ceramic mug of water, taking careful notes on what they were microwaving. They tried and tried and tried, but they ran the microwaves. They worked fine, and nothing happened. The telescope never detected a peryton. They never detected this weird little blast. And finally, someone realized they were being a little too careful as scientists. They were treating the microwaves like they were doing an experiment. They weren't treating it like a hungry person waiting for lunch, watching the microwave counting down and going, well, 4, 3, 2, fine, and opening the door to stop the microwave. We've all done this. We've watched popcorn get almost done popping and just stopped the microwave by pulling the door open. When they did that, when they pulled the door open while the microwave was still running instead of waiting for it to stop, they got a peryton. They explained these big blasts of radio light that they were seeing with the telescope. And when they went back through their data, knowing how to look for microwave signals, they got rid of almost all of them. The one they found in 2007 had been real. We were detecting blasts of radio light from space. Once we'd gotten rid of the microwave noise, these were still there and they were still real. We still don't know what causes them. There's still people actively studying them, but now we know they're not microwaves. I also particularly wanted to tell this radio burst story today because many of you have probably seen radio astronomy in the news today. Radio telescopes made the news this morning thanks to one of our nearest neighbors in the entire universe, the planet Venus. There was an announcement this morning that a strange gas known as phosphine might have been found in the clouds of Venus. So phosphine gas is 1 phosphorus atom and 3 hydrogen atoms. It's really hard to make. We've seen it on Earth, we've seen it in Jupiter and Saturn, but generating phosphine requires really weird and unusual conditions. We can maybe make it in a lab or in weird atmospheres like Jupiter and Saturn, but we didn't expect to see it in a planet like Venus. So if that phosphine gas detection is real, it could be kind of cool. It could mean that we're seeing strange new chemical reactions in the clouds of Venus, which are really weird, extreme places that we still don't understand really well. And one possibility for how to make that new chemical could be microbes. There was this idea that if we have microbes living in the clouds of Venus, they could be generating this phosphine gas. And of course, microbes around another planet would mean life on another planet, which would mean aliens, which means you have an instant headline when you've discovered something like this. So this got all over the news this morning. My colleagues and I have been chatting about it all day, and it featured radio telescopes. Those radio telescopes had taken what's called a spectrum. This is the big, beautiful picture that absolutely nobody used for their headline because it looks a little boring, but to a scientist, it looks awesome. What these scientists did was take light from Venus's clouds and sort it out according to its color. They put the bluest light at one side of a plot and the reddest light at the other side of a plot, and basically tried to see how bright it was at each color. Now, when they got way over into the radio, they saw this funny little dip in the brightness, and they think that that dip is light that's getting blocked by phosphine in the clouds of Venus. They're not sure, and there's still a lot of people researching this discovery, but if they're right, it could be really cool. And it was all done with 2 different radio telescopes. One was a set of radio telescopes called the Atacama Large Millimeter Array down in Chile. These telescopes are built at 16,000 feet of altitude, which makes them perfect for detecting this type of light that has a lot of trouble getting to lower or drier spots on the planet. And they used the James Clerk Maxwell telescope in Hawaii. So this is a radio telescope, but it might look a little weird. You kind of look at it and instead of a dish, you see this big curvy thing. That curvy thing is actually a Gore-Tex shield. It's spread over the radio telescope, but the radio telescope doesn't care. Radio light can puncture straight through that shield and reach the dish without a problem. What can't get through that shield are, say, bird droppings from birds that fly over the telescope. So instead of having to clean the telescope as birds pass over, they can just shield it and leave it be. But these are the telescopes that you can thank today's exciting, maybe aliens news stories on. So the last question that I asked people, how has astronomy changed since they've begun observing? I got a couple pretty consistent answers to this. One was that the technology is changing. We've gone from those photographic plates. So this is an old photographic plate observation of the Andromeda galaxy. It looks nice, but you can kind of see it's this gray fuzzy blob with some sort of weird, hard to see spiral arms around it. We've improved greatly since these observations. These observations were really valuable, but now our picture of the Andromeda galaxy looks like this. We can use the Hubble Space Telescope to detect individual stars in Andromeda and study how they work. So the technological improvements have really revolutionized the types of science that we can do and what we can see in our universe. Another thing that has changed is the way that we observe, our job as stargazers. So this is a picture of me standing in front of an under construction observatory in Chile. It's the Vera C. Rubin Observatory. It's named after the woman who discovered dark matter, and it's going to be a totally new type of telescope coming online in the next year or two. This observatory isn't going to work like Subaru, the telescope I talked about at the start of my talk. I won't go to this observatory and spend a night telling it where to point, picking out specific galaxies, and observing a list of objects that I want. And someone else won't come along the next night and study a list of objects that they want. This telescope instead is going to look back and forth across a huge swath of the sky in the southern hemisphere. It's going to photograph the same patches of sky over and over and over again for 10 years. And that's going to build up a decade-long movie of the night sky and how the night sky changes. That kind of sounds weird because we don't think of the sky as changing that much, but in truth, things are changing in it all the time. Stars are getting brighter and dimmer. They're exploding or disappearing. There might be a new asteroid that we haven't discovered yet that's kind of scooting through the sky, moving at a different speed than the stars around it. And an observatory like this can find all of those things for us. To make a movie of the entire sky for 10 years, this telescope is going to generate a tremendous amount of data. But it can also take that data fairly simply. We don't need a bunch of astronomers and a bunch of staffers at this telescope. It'll be run with almost a skeleton crew of scientists making sure that everything runs. And then the data will automatically be posted online for astronomers to study. So our job as stargazers won't be to go to this telescope. The telescope's data will come to us. And our job might no longer be stargazing on top of a mountain. It'll be sitting at our laptops working with the data and figuring out what it tells us. It's a really efficient and really exciting way to do astronomy. But there's only some astronomy that we can do this day. If you remember that little, do this way. If you remember that little squiggly line from the radio telescopes that we all got excited about today as maybe aliens on Venus, you could never do that with a telescope like this one. What we really need is a great blend of different types of telescopes. We need this wonderful cutting edge new telescope like the Vera Rubin Observatory. We need facilities like the Very Large Array in New Mexico. We need telescopes that we can go to and sit at and point at that one weird thing that we think might be interesting from night to night. And with all of these tools together, we're able to study the universe. The trick really is making sure that we have the support and the funding to build these facilities, to help fund the astronomers that use them, and to keep asking questions, thinking of new things that we can build, and thinking of new things that we can try as we wind up studying the cosmos. So on that note, the last thing I want to bring up is the role of tomorrow's stargazers. This last photo in my talk isn't taken with some gorgeous fancy telescope. This was taken with my iPhone. It was taken of the big famous comet that passed by Earth a couple months ago that I hope a lot of people got the chance to go out and see with the naked eye. This is a photo taken from a pretty badly light polluted park here in Seattle. It's not an astronomically fascinating photo, but I love it because it shows us why astronomy is worth this investment and worth building a bunch of different types of telescopes and supporting scientists. Astronomy really gets to give us this sort of happy, unifying experience. This happened in the middle of the pandemic. It happened when all of us can only be 6 feet apart from one another. I remember going to this park and seeing little groups of people all wearing masks, all carefully clustered away from one another, but all looking at the same thing, all looking up, all taking photos with their phones, totally, but all being really excited by something in the universe. And we've been seeing a lot this year of sort of global scale events that can be very tragic and very sad. And something I love about astronomy is that it can bring us the same sort of global unity and global feeling of being together on the planet and admiring something in the universe through joy. So this to me gets at why astronomy is so important and why we want to continue supporting it and the people that do it and all the wacky adventures we have along the way. So on that note, I'll leave the book information up again, and I'd be happy to answer any questions. Thank you.
Thank you so much. That was fascinating. I love how you ended there, reminding us that we're all under the same but different sky every night. I think that's one thing I love too about stargazing and astronomy, how it really does unify us and also remind us of just how tiny we are as humans on this one little planet in this massive universe.
Oh,
So,
yes.
yeah, I wanted to ask you, you talked a lot about how technology had changed and the field had changed over time since you've been doing astronomy. And you talked about the joys of astronomy, the hopeful nature of it, the science. I wonder if you can tell me a little bit about how you might see astronomy affecting other areas of science or teaching us things maybe about our universe that might help us battle larger problems like, say, climate change or global warming. Do you have any information on that?
Yeah, no, that's a great question. One of the things I really like about astronomy is how multidisciplinary it is. Um, my undergrad degree is in physics, and then I've learned a great deal of chemistry as part of my job. I don't happen to work in this area, but I have colleagues that study geology, biology. I have colleagues that really do incredible things with like very advanced computer science, like algorithm research. So there's certainly tie-ins in that if we can get it very good at something in astronomy, it tends to have practical applications elsewhere. The climate change question is also a great one. The colleagues that I was talking to today about this potential Venus discovery study things like what Earth would look like as a planet in another solar system. If we were studying Earth from ridiculously far away, what would we see? And people talk about things like what would a runaway greenhouse effect look like? What if we discovered aliens and they were unfortunately treating our planet as badly as we're treating ours? Would we see a sign that they're there because of what they were doing to their atmosphere? Or can we see signs of planets that naturally recover from problems in their atmospheres in a way that we could enact here on Earth? So treating us as an entire planet is very natural. It's a very natural perspective for astronomers, and it actually addresses some of the planetary problems that we deal with.
So tell us a little bit about what's happening with astronomy in the West right now with all the forest fires and smoke and everything. Are people still able to do work, and what kind of effect might that have? Do you Do you know what kind of effect that might have on some of the bigger? I know the West has a ton of these large telescopes with such great viewing places normally. This summer is
Yeah.
probably a lot different.
So, living in Seattle, my most immediate connection to all of this is the smoke. We've had incredibly thick smoke. It's making it hard to breathe the air and be outside. And the reach of the smoke is stunning, actually, now. If you look at satellite images, it reaches across much of the US. So, the worst fires are in California and Oregon, and there's fires all over the West. I've talked to colleagues in Arizona and in New Mexico saying we couldn't open the telescope, or we didn't bother opening the telescope because the smoke was so thick we couldn't see anything. Some of the bad fires in California, too, either have been close or are close to some of the major observatories in California. Mount Wilson Observatory is very close to, I think it's the Bobcat fire. And I know that my colleagues and I have been logging on to Mount Wilson's website and looking at webcams that we have mounted. A lot of observatories will put a little webcam on the telescope's dome. Usually it gives us these gorgeous views of the mountain and we get to see the sky at night. And the webcams the past few nights have just shown mountains in flames. It's unsettlingly close to the observatory itself. Mount Wilson is a historic observatory. I write about it a lot in The Last Stargazers, and it's still active and contains a huge amount of sort of American astronomy history. So it's sad to see it in danger. They're keeping the staff safe first and foremost, and a lot of observatories actually wind up being really handy staging areas for firefighting efforts because they have roads up to the summit. But I really hope that my answer to this question in a week is, but it's fine. People were kept safe, the fire was put out, and the observatory survived. But, oh, I hope that's true.
Yeah, I guess with a lot of the more modern ones, they are probably made of materials that should withstand fire. Is that true?
So sometimes there's not much that can be done. A lot of times you want to try and clear, you don't want trees right next to a telescope dome, for example, because you don't want to try and point the telescope at something and have trees in the way. There's another observatory in New Mexico, Apache Point Observatory, that I know that this was part of the consideration, that depending on where you're pointing, you want to avoid some of the beautiful tall trees around. So you can clear material. And obviously modern telescopes will be made of metal. You'll have metal domes and you'll have concrete floors and glass mirrors. But some of these fires are so incredibly hot that even that isn't enough to withstand damage. And there are some observatories that have famously been destroyed in wildfires. In The Last Stargazers, I write about some observatories in Australia that were completely destroyed by brush fires. And one of them was a very strange case where most of the observatory would have been fine, but it was a historical observatory and the wood, it had this beautiful wood parquet floor. And the fire got into the dome, burned the floor, and the heat of the flame was so hot that it basically warped and destroyed the telescope mirror above it. It was enough to cook the mirror. So it's a lot of times in astronomy, we talk about scales of things that we just can't imagine. Like, what does it mean that something's 6 billion light years away? And how much farther is that than 6 million light years away? And I look at some of these fires as sort of the same idea. Like, we can't imagine how hot they get. So we can do a lot to try and make the observatory safe and the people safe, but sometimes there's not much to be done.
Yeah. Yeah, I have plans to go to Puerto Rico and I wanted to visit their newly renovated observatory there, and then it was hit by the hurricane. So I don't know what the
Yeah.
status of that one, but that was in Arecibo, I guess. We were very excited to go check that out.
Yeah, so Arecibo is another one that I write about in the book, and I actually write about its experience in Hurricane Maria. So Arecibo is this incredible radio telescope. It's 1,000 feet across, which is just huge, and it's built into a sinkhole in Puerto Rico. So Arecibo can't turn itself. It's just got a sort of detector above it that can be scooted around on these three big long cables to point at different parts of the sky. And during Hurricane Maria, I know they were actually able to almost keep operating during the hurricane, but the hurricane did cause some damage. It ripped off a piece of one of the detectors and kind of dropped it down through the dish. So it punched a hole in the dish. There was flooding under the dish. I think they wound up taking one of my friend's kayaks out and like riding it under the dish to check it for damage. And it was sad to see that happen, but they were able to repair and keep going. About a month ago, they actually had another accident there. One of those three big cables that I described holding the detector up snapped and punched a hole in part of the main receiver and then again through part of the dish. You might have seen pictures of the dish damage online, which looks very dramatic, but is fixable. The bigger concern was fixing the cable, making sure everything was still suspended safely, and making sure the instruments that they were holding up were still okay. So I know that they've got a lot of repair work ahead of them, but it's a really awesome telescope for radio astronomy. So we're all rooting for it getting the funding and the sort of TLC it needs to get fixed and get back up and running.
Yeah, I would really love to visit that one. So, are there people that specialize then in just repairing telescopes? Are they astronomers or engineers or some kind of s- telescope mechanics out there?
Yeah, no, that's a great question. Um, on the scale of like the Arecibo repair, I think you would be bringing in specialists in sort of the sort of construction and repair industry. But for things like building a telescope's mirror or building the cameras that go on the backs of telescopes, yes, this is an entire specialty and an entire career. There's this amazing lab in Arizona that specializes in creating those 8 meter across mirrors. They'll basically pour glass into a giant oven, heat it up until you've got molten glass, and then the whole oven spins. And if you ever take a glass of water and just like swish it and spin it, you'll see it sort of curve a little bit. And spinning the molten glass gives it the natural curve that you want to see in a telescope mirror. But there's entire crews that specialize in just the optics and design and engineering of that. And then I have colleagues who specialize in building the cameras on the backs of telescopes. These are unbelievably sophisticated and complicated instruments, and they apply for their own grant funding and do their own research. I talked about astronomy being multidisciplinary, and these are folks that become like specialists in mechanical engineering, electrical engineering, optics, like all sorts of subfields just so that we can get started. Someone like me will come in and use the telescope and know honestly very little about the ins and outs and nuts and bolts of how those instruments work, but without the people who do know that, we absolutely could not do our jobs. So it's a really cool job for some people to have, and we're really lucky to have people working on it.
Yeah, it sounds like there are so many different things you can do with this background that you wouldn't necessarily first think of. So I'm excited to read more of your book and see what else you delve into. I wanted to ask you just a couple of questions about yourself more specifically in your research before we get off the meeting. I was reading your bio that you do some research on massive stars and the deaths thereof. Is that correct? Do you want to tell us a little bit more about what you're working on?
Yeah, so I literally study how stars die. Now, when you said massive stars, and I specifically study stars that are way more massive than our own sun. So our sun is a very cool but very kind of typical star. It's about 4.5 billion years old, which, so you know, like middle-aged. It's going to wind up living about 10 billion years, and near the end of the sun's life, it's going to puff up a little, cool off, turn red, and then sort of buff off its outer layers and just peacefully die. I'm interested in the slightly wackier stars. So stars that are about 10 times as massive as our sun or more follow this kind of funky, like live fast, die young philosophy in life. So they live maybe 10 million with an M years instead of 10 billion with a B. And they will actually undergo death as a supernova. So these are stars that will have their cores collapse and then bounce back and hurl all of their stellar material deep into space. They create these big fireworks shows when they die, and then they leave behind something like a black hole. And I'm interested in the physics of how stars are behaving right before they do that. Like, what is that final transition from a normal-ish star to something bizarre like a black hole?
That's so awesome and mind-boggling. So hey, I was reading that you're the winner of a prize this year, the Newton Lacy Pierce Prize in Astronomy. And that
Yes.
is bestowed by the American Astronomical Society to a young astronomer. Congratulations.
Thank you.
Is there a specific research project that you're working on that where you were awarded for the prize?
So the prize is given for specifically observational astronomical research, which is specifically what I write about in the book. You were talking about all the different facets of astronomy that exist, and we tend to think of, within astronomy, we tend to parse ourselves into two categories. There's people who observe, like me, who will actually go to one of these telescopes or use data from these telescopes. And then there's theorists, so people who work very more on the theoretical, mathematical, like fundamental physics side of things. And in reality, of course, the split is a little bit artificial. I do some theoretical research. I have theory colleagues who do some work with observing and with data. And there are people who do all of this and also build our telescopes and build our instruments. But this prize was specifically for observations, which is mostly what I do. And I know that when they granted the prize, it was a sort of general career prize for studying these massive stars right before they die, studying how they die and the physics behind it. So it's less about, one specific thing. Like you hear about the Nobel Prize given for a discovery or something like that. A lot of prizes in astronomy are given for sort of a body of work. And it was a great honor to win this one because it's recognizing a body of work by sort of early career astronomers. So those of us that are still getting started and still doing some of our early research. So it was nice to receive.
That's very, very cool. Congratulations on that.
Thanks.
Who is, I'll close by asking you this. We can also ask Hank if he has any questions. I will close by asking you if you could tell us who is or who are some of your favorite stargazers or hero stargazers that you've looked to in your work in astronomy.
Oh, this is a wonderful question. I've actually been doing a lot of work and reading on sort of what we think of as the heroes of astronomy. I'll say that a couple personal heroes. For one, Vera Rubin, so the woman who that telescope in Chile is named for. She was the woman who discovered dark matter. She's the first woman to have a major telescope facility named after her. And I write about her a lot in the book, in part because of her dark matter discovery, and in part because she was one of the women back in the 1960s that was really breaking down some barriers in astronomy. For a long time, women weren't allowed to be the primary investigators at telescopes. Like we couldn't go and use a telescope under our own name. And women did this anyway. They snuck in as their husband's assistant or as the assistant of someone who didn't know nearly as much about observing as they did. But Vera Rubin was the first woman to observe under her own name at the biggest telescope, at the time, the biggest telescope in the world, the biggest telescope in California. So she's absolutely one of my astronomical heroes. I also, this is a not surprising at all answer for an astronomer who writes books, but Carl Sagan. I loved reading Contact when I was a kid. I got into astronomy in part because my parents watched and loved his Cosmos TV series. And another thing I like about astronomy, and something I always like reminding people of, is some of the discoveries that we think of, we associate with one person. Like you've heard of Edwin Hubble's name, probably because of the Hubble Space Telescope, but he discovered the expansion of the universe. Or you know Einstein's name because of general relativity. But there's discoveries nowadays that don't happen by one person. We detected gravitational waves about 5 years ago, so these little ripples in the fabric of space-time. And that was a discovery made possible by thousands of people. We had to build some of the most weird and sensitive astronomical detectors on the planet, and building them took decades. And the people analyzing and studying the data from that had to have dozens of different specialties. And I really like that the heroes of that job are everybody. They're the people who kept the lights on in the building, and the people who kept the engineering of the detector working, and the guy leading the project who was making sure that everybody was doing their job. So we think of science sometimes as like one smart guy sitting in a room. And I like that the heroes can sometimes be these masses of people that work together toward one kind of really cool question.
Awesome. Absolutely. It seems like it would take a lot of collaboration to get some of these heavier, larger research questions answered. And there's always exciting things happening in astronomy, just like you talked about today with these new discoveries on Venus. So we're thrilled to see what happens in the world of astronomy. We wish you much luck with your new book, Dr. Levesque, The Last Stargazers, hot off the press from Sourcebooks, a wonderful publisher that we've enjoyed working with. If you'd like to pick up a copy of Emily's book, you can do so at bookworks.com. That's BKWRKS.com. Dr. Levesque, thank you so much for your time this evening. We really enjoyed this talk. I learned so much.
Thank you so much.
Thank you.